So yeah, as you said, I'm passionate about blockchain for quite a while, but this is my first actual job. I've been a software engineer for 8 years, but in what we call now Web2. And it's always been my interest to help others, help fellow developers. I was sort of the person who did the onboarding for junior engineers in past companies. And that's why I think developer advocate and developer relations is a good fit for me. Today, I want to show how you can use Subsquid to empower your and quicken your development and make sure that also we can raise the quality of decentralized apps that we create. What is Subsquid? I'm going to explain it in a second. But the purpose of this presentation / workshop is an introduction to Subsquid and why we think that indexing and indexing middlewares are a useful thing. So the end goal is to index Ethereum blockchain and find transaction data and index transaction data on the chain. Let's get started. Here you have the link to this presentation if you want to use it for later. It's just Subsquid -ETH -workshop. So yeah, already done the presentation. The point of indexing is sort of to learn from the lessons of the past. In Web2, there's a lot of bad things and that we're trying to replace today, namely data collection and what like user data collection and what companies do with it. But there's a lot of good stuff in terms of technology. I don't think, and I think that it's not controversial to say that blockchain should be used for everything in every aspect, in every kind of use case. It has a purpose, and the purpose is to secure and validate transactions. But then when you have to read those transactions, you don't necessarily have to pass every time through an RPC node. Web2 companies nowadays don't pass through the main application database for everything. They usually ingest the data and put it in some sort of storage that is adapt and specific for the use case that they want to make of it. So they have data lakes, data warehouses. I didn't write it here, but you have usually even a cache layer for the web server itself. So not everything is served by one single database, but it's actually what's happening today with the blockchain. By doing this, they can serve millions of users, low latencies, they can scale on demand, and they can also do real-time analysis. This is, like I said, not what's happening with the blockchain. We have usually high latency when you visit a page that it's relying completely on the blockchain, even for reads, for fetching data. There's usually high latency. That's why we have scalability issues as well. The user experience is bad, and also there's issues in terms of bugs that you can create when you read directly from the blockchain because you don't know the type of the data you extract often, or it can change. But I want to highlight here, we want to maintain the decentralization of everything. This is very important for blockchain developers. So the approach of Subsquid was to look at it from a an architectural perspective and see that every kind of data processing follows a pipeline, what we call a data pipeline. And usually data pipelines are divided into stages. And it's not true that it has to be one single entity doing everything. This is what is happening in similar solutions nowadays, or the first one that started. Everything from blockchain to the end goal were done by a single application, and that's not correct. We divided it into a modular structure because essentially, at least the ingestion part, it's common for everyone. And so there's wasted effort because of replication. The structure is rigid, so you cannot evolve. And even there's a lot of waste when you have to evolve the application because you have to re-index every time and re-ingest. Where instead, if you have a modular architecture, you can have a shared layer, which is what we call archives. And you lower the cost by lowering the storage and computing power requirements. And in the end, you have better performance. So this is our proposal. It's to have the ingestion and initial normalization into one single service that is shared by all the downstream clients. And we call it archives. When you zoom in, it kind of looks like this. There's an ingestion sort of logic, and there's a data storage which can evolve. It has already evolved in the various generations of archives that we have developed, from a common Postgres database to a distributed database such as CockroachDB. And now we are looking into Parquet files, which are better suited for things like IPFS, for example. Sorry. And all of this is served through Web2 kind of APIs, which are more performant and easier to manage than RPC nodes. And so the downstream processing can fetch the data by filtering it down. So you don't have to request data block by block, but you can just say, I want every transaction from this contract, or in the case of Substrate, for this palette of this event of this palette. Essentially, the archives gives the developer the ability to care about one less thing. It gives you better storage, better performance. Like I said, allows you for filtering and batching, which is not possible with RPC nodes. Yeah, let's say it's not possible. And overall, it reduces the network overhead. On the other hand, what you develop, what you should be interested in is the second part. It's the second part, which we call the ETL, extract, transform, and load, which is fully customizable. We have an SDK, and this is part of what I'm going to show you later on in the workshop part of this presentation. This is where you develop your own custom logic. And it's useful also because oftentimes the contract developer is not the same person as the web app developer. And so by having this middleware, you can decouple the two things. So the front end shouldn't have any influence on the structure of the smart contract. You shouldn't have a fetch my NFTs function in your Solidity smart contract. Because simply it's wrong. You can just index all of the NFTs and then you can filter them by owner. This is done by such an API. Looking into it, once again, zooming in, it's kind of similar. It's sort of like a replication of the architecture. You have the business logic here. You have, in this case, it's still a common Postgres database for simplicity, because also the size of the filtered data is much smaller than what you have with an archive. And you have an API downstream. If you want to, you can also, we have examples of outputting data elsewhere. So you don't necessarily have this. It's just the most common use case, and that's how we suggest doing it in a template repository. So yeah, I already described what squids are. They are this extract, transform, load part of the pipeline, and this is how you can essentially index and process on-chain data. Some of the other good aspects of the SDK is that it's built for devs. And so we have a good emphasis on, a strong emphasis on local development. You can set up your own local squid. It's lightweight and it facilitates the development of your front end because you have basically the API running on your local machine, and it's very lightweight. It syncs up very fast. So even if you want to make changes to your API, you don't have to wait for weeks or days. It's just hours in the worst case, and sometimes even minutes. We have a serverless deployment hosting service, but you can also self-host if you want to. And I mentioned the issues of typings and the bugs that it introduced. We have automatically generated code that looks and respects the types of the on-chain data, so that you don't have to write custom code for it, and it's already done for you, so it should be bug-free, or as much bug-free as possible. Some examples of this are generating, like you write your schema and define it in GraphQL, which is kind of like high-level language, and we generate the TypeScript model for you, respecting the typings correctly. But also we have the typegen for the EVM smart contract from Solana, and for sorry, so not Solana, for Solidity, and the derived API in JSON format, which kind of looks like this. We automatically generate interfaces and decoding functions for you. So essentially, you just say, I want to index the transfer event of this ERC721 smart contract, and we already have the interface defining the correct types for you. And this is exactly what we're going to see in a few seconds. So if you want to take a look at the documentation and dive deeper, this is the there's links in here, but it's simply docs.subsquid.io. And there's a few templates in our GitHub account, github.com/subsquid. And Aquarium, I'm going to show it in a second. It's kind of like a gallery of squids, which are these APIs, and you can just play around, play around with the API, but you can also check out the code and see how it's done. It's basically learning by example. But let's get coding. So the goal of today is to index this Exosama NFT collection. This is on Ethereum, and it's relevant in my opinion to SBTs, because in the end, the Soulbound tokens will be tokens, and so you can track maybe a different event, obviously a different contract, but they can be tracked at the same in the same way. Essentially, it's just going to be necessary to change things around, but the principle stays the same. So the goal, the path, the flow to obtain the end goal is to start with the setup, review the schema. We are generating the models like I showed earlier, generating the interfaces for the smart contract. We're going to implement these, the business logic, launch the local database container. We need Docker. And apply the migrations. So essentially create the database schema for us automatically, launch the processor and GraphQL server, and just see the result. Like I said, we need Docker, but we also need Node.js. Every squid is essentially a Node.js project with the Subsquid SDK added on top. This is the template, like I mentioned. It's Subsquid Squid Ethereum template. Maybe I need to zoom in a little bit. And we can click here, use this template, create a new repository. But in my case, I actually already have it ready here. And so we can start. I need to open the terminal and install the dependencies that I have here. I need to zoom in as well, probably better. There's a few of them, so it's going to take a moment. But yeah, in the meantime, let's go back to the presentation. So like I said, we clone the repository, enter, and install the packages. Next, I have already thought about the schema that I want in the end. I'm going to copy it in the project, and then I'm going to explain the choices that I made. This is completely arbitrary. This is where I said it's up to the developer to decide, and it's kind of decoupling the structure of the smart contract from the structure of the API and of the front end. So I'm going to take this schema.graphql file. It contains just a dummy entity in here, and I'm going to paste this in. So I decided on these 4 entities. An entity is basically mapping to a table on the database in the end. I'm going to have a transfer table, a contract table, an owner table, and a token table. And the sort of decorator is telling exactly that. It's basically specifying that this data should be persisted as a table. I decided on a few fields, like every token should have an ID, an owner, of course, the URI, which contains the metadata, and I want to store the transfers. This is mainly the main thing that we're going to index in this application, this API. But also wanted to preserve the relationship, the contract, because obviously an ERC 721 contract has many tokens attached to it, so I'm preserving this relationship in here. But also every owner is designed like it has its own ID, which is the address, and it owns some tokens. This is same as this one. It's a one-to-many because it's an array. It's a one-to-many relationship, and it has a balance. Nothing controversial here, I guess. I decided to also capture the contract in here because of the relationship, and it has, the ID, name, symbol, contract URL, the address, and I think this is not necessary, but I guess we'll see. I don't remember why I put it here, honestly. And the total supply is the total number of NFTs that are attached to the smart contract. In the end, this should be the length of this array, pretty much. And once again, minted tokens is how many tokens are part of this contract. And once again, this is the main thing that we're going to index today. So for every token, every time there's a transfer, we're going to create a new object in this table, and it's just going to tell us who sold it to who, when, and which block has this transaction, etc. So let's move on. When I run this command, I'm going to generate a few TypeScript files, and I'm going to show you really quickly. So like the image showed, in this folder, source, model, generated, I have these files that have been generated for me. Let's see the owner here. And it's basically reflecting what I have defined here. It has 3 fields, an ID, the tokens, and the balance. And I have an ID, the tokens, and the balance. The presentation shows the same thing, so we're good. Now, next, I need the smart contract ABI. Usually, it's quite easy. If you go on Ether, I think I need to, If you go to Ether scan anywhere, I had it in the history. It's the ENS, Ethereum name service. You have the contract here, and you can fetch the ABI from here, right? In this case, I have it saved somewhere else for simplicity, but essentially it's the smart contract ABI. It's sort of like an augmented ERC 721 contract. Let's go back to full screen. So I'm going to create a folder here named ABI, just because I want to keep things tidy, and I'm going to create a file named exo.json. So I don't know how many of you are familiar. I hope it's nothing new, but the ABI is the interface towards the contract. It's telling me that it has, for example, the approval event, and these are the inputs. So it's telling me that this address has approved for this address. And you have to know a little bit of logic to know how it works. What I'm interested in is, let's see, transfer, this one. This is an event that is emitted every time the NFT is transferred, and it has these fields, the from, to, and the token ID. So it means that this guy transferred to this guy this token. Pretty simple. And I'm going to use once again, our SDK to automatically generate a TypeScript file containing TypeScript interfaces for this JSON file. And there it is. It's kind of like a bigger version of what I had earlier in the presentation. It has created types for all of the events and down low even all of the functions, right? In here, if we go back again, and it has created this nice dictionary here of all the events, and for each event's topic, it's exposing a decode function. This is what we're going to use for the, let me see, transfer. Okay, moving on. I'm going to create an auxiliary file just to store, for simplicity for today's presentation, I'm going to hard code all of the information regarding the contract. But it's actually pretty easily, you can pretty easily fetch all of the information of the contract just by using, sorry if I scroll a little bit because of the zoom in, there's a lot less things that fit in the screen. Part of this file is also a class named contract. This is how we can directly interact with the contract on chain. It's basically a wrapper around the Ethers library. And I can get, for example, let me see, the URI of the contract itself. And I can get the total supply, I can get the symbol. So I can get some information directly from the contract itself. Instead, what I decided to do for simplicity, for making it easier, new file, I'm going to create a contract.ts and hard code it. Because I already know all of this information, the information of a contract shouldn't change much dynamically, and so it's just easier for me. Next, once again, the processor logic. I'm going to copy it again and paste it and explain it step by step. Here in the template repository, there's once again dummy code. It's just looking at the black hole contract, and it's just saying, hey, I found something. That's it. We're going to make it a little bit more complex. Starting from the top, the first thing that you should be doing when creating a Squid project is instantiating the processor. This is the protagonist. This is what's doing everything, essentially. This class can be configured. In this case, I'm saying I don't want to start from the start of the blockchain. I'm starting from this block number because I know that this smart contract has been deployed right after this block. And so I'm saving a lot of time. I'm setting the data source. I'm setting what exactly I want to index. I have this smart contract address, which is here. It's a constant. Once again, it's information I know already. But like if you want to index a certain smart contract, of course actually, you know what? I think it's nice to go here and search it. You should be able to see it. Yeah. So it doesn't have official information. Oh yeah, there it is. It's like I said, it's the Exosama collection. So that's how you usually can find stuff around. Let's say we want to go back to the ENS. I'm going to type ENS in Ethereum service. There's the token, the ERC20, but there's also the ERC721, which is how the actual Ethereum names are stored. You see. Going back to the logic in here, so you can configure it. Here I'm saying I want the information for this smart contract, and I only want the transfers, right? Then I can further filter down. When I request information from the archive, I can say I only want the topics, the data, and the transaction of the EVM log. That's it. Then I'm launching the processor. I'm just saying processor.run. I provide the database interface, and this is where all the logic gets executed. I have this sort of like a callback, this asynchronous function that is called every time I receive a batch from the archive. A batch, it means that the archive is sending me multiple blocks containing multiple items, and this is why I have to loop through them. These are just checks to make sure that I receive the right information. I'm checking that I actually got the EVM log and I actually got the information from the right smart contract. And then I'm calling this handle transfer function in here. And I am using the file that I created earlier, this exo.ts, the events dictionary of mapping that I showed you earlier, and using the decode function in it, we can just look into it. I'm using this exact function here to decode the event of the transfer, to decode the event information of the transfer event. And then I'm putting it into just an interface that is nice for me, just to store every transaction that has been found in this batch. And I collect them all, just to show you, I collect them all into an array. And at the end of the batch, I save them all. This is done. I'm going to show you the function really quickly. This is done to save a lot of performance, because if I were to save them one by one, it's going to be a lot of back and forth with the database, and it's going to decrease the performance quite a lot. So the point of what we're doing here is requesting information in bulk, processing it in bulk, saving it in bulk, and it's much faster than doing it all one by one. The saving is not very interesting stuff. It's just going through the array of things and instantiating the models that I showed you earlier, the ones that we have here. These models are essentially interfaces towards the database. It's how the tables are going to be filled. I'm going to have a token table, an owner table, a contract table, and most importantly, a transfers table. I want to show you something really quickly. This is the contract API that I showed you earlier. It's the how we can communicate directly with the on-chain contract. And just to show you how fast archives are, I'm going to comment it out. And because this is the only slow operation that we have, the rest is conducted directly to the archive. This is the only interaction with the RPC node, with the Ethereum node that we have in here. So I'm going to leave it commented out. I'm going to leave the token URI empty. And I think the next step is to just, oh yeah, I forgot. Of course, to connect to an Ethereum node, we have to provide it. And this is what, sorry, if I go back to the top, this is what this environment variable is. We have an env file in here. I have my private Infura Ethereum node, essentially, that I'm running on a free tier. I'm not paying. So yeah, that's it. I think the next step is, launch the database. I'm going to show you how it's launched. It's basically this Docker compose here. We have a Postgres database, simple configuration. So let's do it. Yep. We can check. Yes, we have the Postgres database running. And then another thing is we have migrations I mentioned earlier. So in this database DB folder, we have migrations, which are a series of SQL statements to create the tables for us. This is for the dummy entity we had, so we need to delete it. Sorry. No, I actually accidentally opened this folder. Okay. And so make migration. Oh, yeah, forgot to npm non-build. I forgot to build the project, of course. Should be better now. Good. So it has created a new one for us. It's creating tables, it's creating indexes, etc., etc. Should be good. So now we can launch the processor, and then we have a separate command to launch the GraphQL server. This is blocking the terminal because it's giving me some logs. I'm going to show you. While it's running, yeah, you can see it's ingesting data pretty fast. It's like 3,000 blocks per second. It's mapping a lot of items. This is because these blocks contain a lot of transactions. In the end, the mint is still a transfer. So that's why it's going relatively slow. It should be picking up speed next. But let's go on and launch the GraphQL server. Sorry, I have another server running somewhere. There it is. The port was occupied, so it wasn't happy. Okay, we should be good. Here, this is just a local GraphQL server that I'm running, and I have the playground for free. I can check how many transfers we have, for example. And for now, we're counting 20,000 transfers because the total number, the total collection is 10,000, and I guess we have a few other transfers bonus. We can check a single transfer, for example. It's usually always better to put a limit, otherwise the query can basically fetch all of them, and I don't want all 20,000 transfers here. I'm gonna probably crash my laptop. Let's see some information. Yeah, that's it. Okay. So for every transfer, I have the ID of the transfer itself. I have the block that contained it. I have the address of who sent it, and I have the address of who received it. Like I said, all of this, like the first few transactions are actually minting because they come from nowhere. They come from the void address. If I order it, probably timestamp descending, I'm going to get the latest one, and these are actual transfers. This is this address that sent it to this address. And if I want to, I could potentially, it depends on the contract, but I could index the price as well. If the contract, smart contract had the price information, I could store it here and show it, for example. This pretty much concludes the presentation. Let's go back to it. So this is our first beta sort of adventure into Ethereum. We started from the Polkadot ecosystem, indexing Substrate, but as you can see, it works. already nicely. We're improving daily on a daily basis. And I already showed you the aquarium, but what I didn't show you is that this project is actually already available here. You can check out the code, and it does have the token URL, not like I commented out here. I don't think I have time to show you, but if I were to remove the comments and restart the server, it would be much, much slower because it's looking up the token URL directly on the RPC node. Sorry, going back to the presentation. Like I said, what can you do with all of this? Why it's useful to you? Because essentially you can pick any contract, and depending on the structure of the contract, you have access to different information, and you can do pretty much whatever you want to. There's an example in the aquarium where I index ERC20 tokens and fetch the price on CoinGecko, for example, or an external API similar to CoinGecko. And that is useful because that information usually is not on chain. And that's why the flexibility of the SDK and your custom processing logic is a very powerful thing. It's just like I say here, we ingest the blocks and you just decide how you want to process it. So thank you for the attention. Thank you for having me, and I hope you enjoyed it and that it was useful to you, and I hope you make good use of it.